Okay, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. And this is the outline for this week, week 4. So to start with, today I'll discuss a few examples to wrap up chapter 2. And then today is also the due for submission quiz 3. And you need to submit it via e-learning by the latest 11:59 p.m. Secondly, I'll be giving you quiz 4. This is a group quiz, so you need to check your group members' name in the attachment, and then you need to solve the questions and submit it by 19th of November. So in order to do that, you need to perform, first you need to show proof of online meetings with your group members. So either via Zoom, Google Meet, or any other platforms. So you need to have all attendance during that meeting. Secondly, you need to submit all answer via the e-learning on 19th of November. So there are 2 questions in the quiz 4. So you need to answer, each group need to answer both. And lastly, in the group list, I will also provide a question. I will mention which question you need to submit a video. So you need to prepare a short video explaining how you answer that particular question. So this video, you can upload it in the YouTube and share the link into the Telegram by 19th of November as well. Okay, so on Thursday, 19th of November, you need to submit the answer via the e-learning, and secondly, the video should be submitted into the Telegram. And on Thursday also, I will upload more examples on Fourier series, so you can have self-study. Okay, let's look at the first example. Given a signal as shown, xt equal to cos pi t plus 3j sine 2 pi t. So you need to determine the fundamental angular frequency and period of signal xt. So what is the fundamental angular frequency? It is omega naught in radian per second, and the period of signal is t. Okay, and then the second question, you need to express in exponential form, and then you need to sketch both the magnitude and phase spectrum. Okay, the first question asks you to get the fundamental angular frequency and also the period of signal. So to start with, you need to look at the arrangement of the equation. Okay, usually the first component will give you the first harmonic, followed by second harmonics, and etc. If you have third harmonic, fourth harmonic, and so on. The same goes to when you have a graph, a single-sided spectrum for trigonometric equation. Okay, so the first signal represents the first harmonic, and the second one represents the second harmonic. So next you need to compare with general equation. So this is the general equation. Xt equal to cos omega naught t, or cos omega 1 t. So in this case, this is the given equation. So you can compare directly. Omega 1 in this case equal to pi radian per second. Okay, so omega 1 equal to 2 pi f in hertz equal to pi radian per second. If the question asks you for f, the frequency in hertz, so you can calculate the f by dividing omega with 2 pi. So because omega equal to 2 pi f. So in this case, f equal to 0.5 hertz. So don't forget, you have two components to be solved. So this is the omega and the second one is the period. So you have solved the first one either in radian per second or in hertz, but the question asks you the angular frequency, so it is usually in radian per second. But if you provide both answers, also accepted. So next you need to calculate the period of signal. So from here, omega equal to 2 pi f, or it is also equal to 2 pi over t. So you can calculate your period. Okay, so t equal to 2 pi over omega, in which it is 2 seconds. Don't forget to write the unit as well. Okay, secondly, you need to express the given equation in exponential form and then sketch both the magnitude and phase spectrum. So in order to convert the trigonometric equation into exponential form, so you need to remember the Euler's equation or Euler's theorem for both the sine and cosine. And then you need to check for frequency sharing between components. Okay, look at the first component and the second component. So the first omega is pi omega 1. But omega 2 is 2 pi. So there's no frequency sharing. Okay, when there's no frequency sharing, then you can start solve the exponential Fourier series by converting the cos and sine function using Euler's theorem. So the first component is cos, so it is e j whatever in the bracket plus e minus j pi t divided by 2, and for the sine component 3j ej 2 pi t minus e minus j 2 pi t divided by 2j, and then simplify the equation. So this is your equation in trigonometric form. So next, don't forget you have two questions to answer. This is the first one and the second one is sketch. Then once you have the equation in exponential form, then you can sketch the magnitude of the signal. Okay, so this is for positive pi, you have amplitude of 0.5, negative pi, you have amplitude 0.5 as well, and then at 2 pi and negative 2 pi, both magnitude 3/2 or 1.5. So this is the magnitude, although here is negative, but here is modulus, so you have all positive amplitude. Okay, next the phase. So you need to check each component. So the first one is at positive pi, so the phase is, the theta is 0. There's no theta, so it is 0. Same goes to negative pi and also 2 pi. So all zeros here. And last one, there's no phase here, but you have negative sign. So to convert negative sign, if you recall back in the first topic of the second chapter, there's one page, I think the last page in the first lecture notes. So when you have negative, it is equivalent to e j pi. So in this case, to convert this negative into positive, so you need to multiply this equation by e j pi. So you have e negative j 2 pi t multiply with e j pi. So you have a phase shift of pi. So that's why at negative 2 pi, there's phase shift of pi to convert the negative into positive. Okay, let's look at the second example. So given a periodic signal ft, as the equation shown. So you need to predict and sketch the waveform. So what is waveform? Waveform is the signal in time domain. Okay, so the signal must be having shape, okay, depending on whatever shape it is, and it is in time domain. Okay, and then you need to justify your answer. So how to justify is by showing your calculation, your consideration, and state your assumption clearly in your answer or in your solution. So secondly, you need to write the trigonometric equation of signal ft. So the equation given is in exponential form. So you need to convert the equation into trigonometric form. Okay, let's look at how to solve the first question. By referring to Fourier coefficients table, you need to predict and sketch the waveform. Okay, so let's look at the table, and don't forget to compare the given equation with general equation of complex exponential form. So you have the C0 plus the Cn, the coefficients. So obviously from the given equation, the first one is the C0 followed by Cn, Ejn omega t. So this is your Cn and C minus n, and followed by C2n and C minus 2n. So then you need to refer to Fourier coefficients table and look at more or less similar shape of C0 and Cn equation to the given equation. So from the table, these are the two signals that having the C0 and Cn more or less similar as the equation shown. So this column is for your C0 and this column for your Cn. If you look at the C0 of the full wave rectified signal, so you have the denominator as pi, same goes to this and this. Okay, so from here you can calculate the x0. Okay, so you need to check the C0 and x0 for both signal number 4 and number 5. So this is signal number 4 and signal number 5. So for signal number 4, C0 given from the equation is 2 over pi. Okay, so compared to the equation from the table is 2x0 over pi. So from here, the x0 equal to 1. So if you choose signal number 5, so again the C0 equal to 2 over pi. So the equation shown for signal number 5 is x0 over pi. So from here you get x0 equal to 2. But still you don't know which one is your actual signal. Okay, in the previous slide, we have considered the C0. And next step, you need to consider the Cn by using the x0 that have been calculated earlier. Okay, so again, refer to the table for the Cn equation for both signal number 4 and signal number 5. So don't forget to look at the comments or remark as well. So this equation validates for all n values, but for signal number 5, C0 will be zeros for n odd except C1. Okay, if you have n equal to 1, so C1 equal to this equation. So let's look at the given equation. So first consider the signal number 4. So from the earlier calculation, so we have x0 for signal number 4 equal to 1. So then Cn, assuming that n equal to 1, so replace the n equal to 1 into Cn equation of signal number 4. So in this case, C1 equal to negative 2x0, in which x0 equal to 1 divided by pi for n squared. So in this case, n equal to 1, and you get the answer equal to negative 2 divided by 3 pi. Okay, if you compare this one to this one, so it is more or less equivalent, or it is similar, but we need to check signal number 5. For signal number 5, x0 from earlier calculation equal to 2. So again, we consider the same n equal to 1. So now you need to replace Cn equation with n equal to 1. But don't forget to look at the remark. Cn will be zeros for all n odd number except C1. So now when n equal to 1, you need to use this equation. This is for C1. So C1 equal to negative jx0 divided by 4. J, this is your x0, divided by 4. So it's basically equal to negative 2j divided by 4. But if you compare with the given equation is negative 2 divided by 3 pi. So this is the given equation. So obviously, from the comparison, signal number 4 is the best one that suits the given equation. So next, you need to sketch the signal. Okay, first, sketch the signal from the table, because we want to know which variables or parameter to be addressed in our sketch. Okay, next you need to consider the x0 values. This is, so we choose signal number 4, and then the x0 equal to 1, while the t0 you need to calculate from the omega. So from this equation, so this is E, J, and omega t. Okay, so n in this case equal to 1. So your omega 1 equal to 2. So here your n equal to 1. So your omega equal to 2. So from this omega you can calculate your t, which is equal to pi second. So here you have pi, the unit is second. Then you can sketch your final answer or final signal. So it is full wave rectified. So replace x0 with the value equal to 1 and t0 equal to pi, and the unit is second. Okay, in the second question, you need to write the trigonometric equation for the given signal. So the given signal is in exponential form. So to convert the exponential form into trigonometric equation, so you need to use Euler's equation or Euler's theorem, both the sine and cosine. So you need to derive the equation. So the first step is to group the signal with same frequency. So in this case, J2 and negative J2, and J4t and negative J4t. So group them up, and then next step, you need to change the shape of the equation into either sine or cosine, Euler's theorem in exponential form. So in this case, to get into cosine equation, the signal must be divided by 2. Okay, but here there's no division by 2, so you introduce divided by 2, and don't forget to multiply on top with 2. Same goes to the second component. Okay, so the final answer, the trigonometric equation of signal ft equal to this. Okay, now let's look at the third example. So given the full wave rectified signal, and this signal is basically the input signal into this circuit. So you need to solve for 3 sub-questions. The first one, determine the fundamental angular frequency omega naught in radian per second. Secondly, you need to express the Fourier series in the trigonometric form for up to second harmonic. Up to second harmonic meaning that you need to consider n equal to 0, n equal to positive 1, and n equal to negative 1. Same goes to n equal to positive 2 and also n equal to negative 2. Okay, when it's set up to n harmonics or second harmonic in this case, so you need to consider both the positive and negative values. Thirdly, you need to determine the trigonometric cosine Fourier series for the current drawn from the source. So you need to determine the Fourier series of this it in cosine function. Okay, the first question asks you to determine the fundamental angular frequency omega naught for the given signal Vt. So Fourier series basically representing the periodic signal. So from this figure for the given signal, so this is the fundamental shape in which it repeats itself multiple times. Okay, so from here you know that the signal, the fundamental period is t equal to 10, don't forget the unit, millisecond. Okay, so from t you can calculate the omega. So t equal to 10 milliseconds, so omega equal to 2 pi f or 2 pi over t. So you can get the omega fundamental angular frequency equal to 200 pi radian per second. Okay, the second question, you need to represent the Fourier series of Vt in trigonometric form for up to second harmonics. Remember, you need to consider both the positive and negative values of n. Okay, so for the given signal, so this is the given signal. So to get the equation, so you need to compare the given signal with the signal in Fourier series coefficients table. So this is the closest shape. Again, as earlier example, it is full wave rectified signal. So you can get the x0 and t0 value straight away by comparing the given signal and the signal in the table. So in this case, your x0 equal to 12 volt, and then your t0 is equal to 10 millisecond. So from t0 equal to 10 millisecond, you have calculated in the first question the omega naught equal to 200 pi radian per second. Okay, then you need to write down the general equation. Don't forget the general equation Vt equal to C naught plus the summation of Cn, Ej, and omega naught t. So n from negative infinity to infinity. So in this case, from the table, your C naught equal to 2x naught over pi, and your Cn equal to this equation. Okay, this equation Ej and omega t. So you can replace your omega with 200 pi radian per second. You can replace your x naught as well. Then you need to consider n 0, 1, minus 1, 2, and minus 2. Okay, once you have the general equation, when you have replaced all the x0 and omega value, so this is your omega value, and this is your x0 values. Okay, next you need to replace n values for up to the second harmonics. So you expand the equation by including the n values. So this is when n equal to 1, this is n equal to -1, and this is for n equal to 2, and last one n equal to -2. So expand the equation and simplify up to here. So then you need to compare with Euler's equation. You need to have your equation in shape, either in cosine or sine shape. So for cosine shape is E positive frequency plus E minus negative frequency divided by 2. Okay, so from your earlier equation, there's no division by 2. So when you divide by 2, you need to multiply on top by 2. Same goes to the second component. Okay, so now you already have the equation in cosine shape. Then you can convert the exponential form into trigonometric form. So this is the final answer of your equation in trigonometric form. Okay, next you need to determine the trigonometric cosine Fourier series for the current drawn from the source. So the current drawn from the source is IT. So from basic circuit theory, so you can represent this circuit into this. So you have the total impedance Zn, so in which this is when R in parallel with XC. So this is your IT and this is the source VT. Okay, so don't forget the XC is equal to 1 over J and omega naught C. Okay, so to calculate I, you need to divide the VT with the total impedance. So for Fourier series, you need to consider the sequence or the harmonics. So your n depending on the required n. So for this particular question, you need to determine n up to second harmonics. So n up to 2. So here your total impedance when R in parallel with XC. So XC is 1 over J and omega naught C. So you get this equation. So omega naught equal to 200 pi radian per second. Your R is 5000 ohm and C is 1 microfarad. So then you need to replace your n. So for n equal to 0, so your Z naught equal to R. So when n equal to 1, replace the equation with n equal to 1 and replace all values. So your impedance at n equal to 1 equal to these values. So this is 1 times omega naught. This is your R and this is your C. So then you need to convert this rectangular form into polar form. So same goes to when n equal to 2. So Z2 replace all n with 2. So this is n multiplied with omega naught. So n equal to 2, omega naught is 200 pi. Okay, and then convert this into polar form. So you already have all the impedance values. So you already have Z0, Z1 and Z2. Now you need to derive the final equation of IT. Okay, so IT is now VT divided by Zn. So this is your V0. This is your V1T. And next is V2T. Okay, so you need to divide with the impedance, the calculated impedance. So this is your V0, this is your V1, and this is your V2. So the final answer of cosine Fourier series of IT, so this is in cosine form, Fourier series of IT is this equation in milliampere. Okay, so to end the session today, so first I would like to remind you to submit quiz 3 via e-learning. Secondly, check your group member's name. Okay, so then you can start meetings with your group members. So you need to show proof of online meetings with your group members. Secondly, answer all questions. Okay, so this is for quiz 4. And you need to prepare a short video explaining one of the answer. There are 2 questions, so in the list I'll let you know which question that your group need to prepare or explain via the video. So thirdly, quiz 4 need to be submitted on 19th of November. Okay, so the video link can be shared in the Telegram, while all answers you need to upload it in the e-learning, but only 1 submission per group. And on Thursday, 19th of November, I'll upload more example on Fourier series and you can do self-study. If you have any question, please share in the Telegram or you can personally message me. Okay, thank you.